So the next several lessons are going to showcase a case study that demonstrates the use of parallel streams. This will be very straightforward. I just want to make sure that we've got at least a couple of videos where I show you literally how to program with parallel streams to make it easier to do your assignment. I think you could have figured this out on your own, but it's nice to kind of see the big picture. And it also gives me a chance to talk about some of the benefits and potential drawbacks to parallel streams. So this particular example is from my Search Stream Gang case study. And as I mentioned before, it's got a whole slew of different strategies for searching the complete works of William Shakespeare for various search phrases. We're going to talk about a handful of them here. There's other ones we may talk about later in other contexts. So we're going to focus on the use of parallel streams in the Search with Parallel Streams class, and in particular in its process stream and process input hook methods. And this is what these methods look like. I will talk about them in more detail in a second. This is the one that's used for process stream, and this is the one that's used for process input. And what's important about all this stuff is that it's going to showcase the use of some of the operators we've talked about before, like map, filter, and collect. And you get to see how they all work in the parallel streams context. So the first method we talk about here is called process stream. The framework invokes this method to make everything work in a consistent way, to make apples-to-apples comparisons legitimate. And it uses a parallel stream to search a list of input strings where each input string contains a work of Shakespeare. So Hamlet, Macbeth, Tempest or The Tempest, Merchant of Venice, name your favorite Shakespeare stuff, it's all in there. And this parallel stream uses the common fork-join pool of worker threads to process each of those input strings, each work of Shakespeare, in parallel. So the processing of Hamlet will be done in a different context, different thread than, or different processor core ultimately, than say Macbeth or Merchant of Venice or whatever. What's returned from process stream is a list of lists of search results. And if we have time to walk through the example in more detail, you'll see why we have a list of lists. And then we use flat map to flatten those things. The other method, which is actually called as a kind of as a subroutine of process stream, is called process input. And this uses another parallel stream to search each input string, so like Hamlet, for example, to locate all the occurrences of phrases that we're interested in finding. So if we want to look up, neither a borrower nor a lender be, or my horse, my kingdom for a horse, or pick your favorite Shakespeare phrase like et tu Brute or whatnot. Those searches will also be done in parallel on each input string. And once again, all that processing is going to be using the common fork-join pool. So we have a bunch of threads, and as these things are chunked up, they're handed off to the fork-join pool, and then when it's their time to run, the fork-join pool, some worker thread in the fork-join pool will take that chunk and do its thing in parallel to other chunks that are taking place. This returns a list of search results. So these are all the things that matched, if any, from the phrases for that work of Shakespeare. So that kind of gives you a high-level view of the various pieces here. Obviously, if you read the right-hand part of the slide, you can see the code that's being called. I'll break that down, and we'll take a look at this in more detail here shortly. We'll visualize it first, and then we'll look at the actual code in more detail. But that's basically what's going on. So you can see we have parallelism in 2 dimensions. We have parallelism for each work of Shakespeare. Each work of Shakespeare runs in a separate worker thread. And then for each work of Shakespeare, the searching for the phrases, because there could be lots of phrases you want to find, those all run in parallel as well. So again, parallel in 2 dimensions, parallelism in 2 dimensions. So that's the overview of the Search with Parallel Streams case study. We'll look at more details here momentarily.